Hi everyone, welcome back to my channel. In this video, we are to learn like terms in algebra. Let's refer to one live scenario. Suppose you have an apple and your dad has 3 apples. So you can say that you and your dad have 4 apples altogether. And in algebra, like terms are algebraic terms with the same variable raised to the same exponents. So if you are to look at the condition, you have 2 conditions to require, that they are the same variable and they has to be raised to the same power. Only their coefficient can differ. Let me ask you a question. Do you think 3x and 5x are like terms? So you should first see that they are the same variable. So they both are x, which is great. So they match condition 1. And you need to see that they raised to the same power. So I believe you have an invisible one. So definitely they are raised to the same power. And since they met 2 conditions, so we say 3x and 5x are like terms. Moving on, if I am to ask you 4x squared and 7x, do you think that they are like terms? So we first look at the variable, right? They are the same variable x, but you see that they are raised to a different power. The first is raised to 2, while the second is raised to 1. So this is not a like term. It does not satisfy the condition 2. Moving on, let's look at this example where you have 3ab squared and 4ab squared. So this time you have 2 variables. You need to treat the 2 variables as a single object. This is what I mean. You are to include the 2 variables together. So let's look at our first condition. So you have a and b in the first term and a and b in the second term. They are absolutely the same. And I believe this a raises to the power 1 and your second a raises to the power 1 also. And that's right, but you have to look at b as well. So b are raised to 2 and 2. So both are raised to the same power. So we say that this pair is like term. 4a, b, and a squared b. Remember, we are to treat the variables as a single object. You have AB and AB, right? The variables are the same. And you have A raised to the power 1, while your second A is raised to the power 2. So we can just not looking at B because the A's are not matched. So definitely they are not like terms. Let's look at the last example we have. The first you have 4xy, and the next you have 2xz. So always remember that you have to treat them as a single object. And if you refer to your first condition, you have x and y, and the other you have x and z, although x matches, but y and z does not match, and we say that this pair is not like terms. And you do not need to check the power because you need to satisfy both the condition in order for us to say that they are like terms. Moving on, we are to collect like terms. So let's refer to this expression and we are to find the like terms in this expression. So let me find it for you. I believe you have x and x. They have the same variable and they are raised to the same power, 1. So we can collect the two like terms. So you can think of this x as an apple. You have four apples plus another two apples. How many apples would you get? So you get six apples. Or if you are to perform it mathematically, you are to factor out the x because I have x in common in these two terms. So I am to factor out the x and I am to perform the addition inside the parentheses. So 4 plus 2. And if you are to simplify the parentheses, you get 6. And you can directly attach your x to the coefficient. Moving on, besides variables, your numbers are like terms as well. So you can simplify minus 5 and plus 4. So you bring them together, you have minus 5 plus 4, and you are required to perform basic arithmetic. So I believe you should get minus 1. The last, we have this plus 5y, which does not have a like term. So we are to directly bring this 5y down. And this expression tells us that we have successfully collected the like terms. Moving on, we are to look at another example. So let's start to collect the like terms from this x to the power 2. And you are to look at if there are any x to the power 2. In other terms, I believe there is. So think of this x. So let's just bring them together. You have 5x to the power 2 minus 3x to the power 2. So you should always bring this minus with you. And we are to collect the like terms. So you have 5 apples minus 3 apples. I believe that should give you 2 apples. Or if you are to perform mathematically, you see that x squared is common in both terms. You are to factor the x squared out and perform the subtraction in a parenthesis. And I believe you should get 2x squared. So let's start from this y. So this y, let's see if there is any like terms. I believe this y has two other like terms. You have this y and y. So we try to bring the y's together. So minus 2y plus 4y plus 3y. So suppose you have minus 2 apple plus 4 apple and plus 3 apple. So you are to do the arithmetic. So I suppose you should have your y factored and minus 2 plus 4 plus 3. Do the arithmetic in the parentheses. And I believe you should get plus 5y. The last, we have minus 6x, which has no pair to collect with. So we are to bring this minus 6x down. So I believe you should get your simplified expression as 2x squared plus 5y minus 6x. The last example we have, and you can see we have two variables. So let's pair up the like terms carefully. The first, you have a squared b. So I'm to find if any other terms has a squared b. Be careful. I believe you get this a squared b here. So let's bring the a squared b together. So 7a squared b minus 2a squared b. So you are to factor out the a squared b and perform the subtraction. 7 minus 2. So I believe you should have 5a squared b. The next, I believe you have this ab squared. You are to look for other ab squared. So I believe these are the only pair you have. So plus 4ab squared minus 6ab squared. You have ab squared in common, so factor the ab squared out and perform the 4 minus 6 inside the parentheses. You ultimately should have minus 2ab squared. And the last, we have this ab with no pair to collect with, so you are to bring this 9ab down, so plus 9ab plus 9ab. And this is your final solution. If you like this video, don't forget to subscribe.